When we started this chapter, we said we were going to be talking about rational functions. Those are functions in the form f of x is equal to g of x over h of x, where g and h are polynomials. We started off by talking about probably the most simple kind, which is a reciprocal function. F of x is equal to some number 5 over x. It could be any number over x. We said we have a vertical asymptote at the y-axis, horizontal asymptote at the x-axis, and we know that it goes through 5, 1, 1, 5, negative 5, negative 1, negative 1, negative 5. So we can get points there. We could state our domain and range by knowing our asymptotes. We could get a lot of information off of that. Then we looked at transforming that into another one, and we said we'll call this one j of x. We said j of x is going to be 5 over x minus 3 plus 2. And what that did is move the graph 3 to the right, so my vertical asymptote is x equal 3. And it moved the graph 2 spaces up, so my horizontal asymptote now is y equals 2. But this does not meet this form. So how do we make it meet that form? What we do is we add these together, 5x minus 3 plus, I need a common denominator of x minus 3, so that's going to be 2 times x minus 3. Then I'll combine those into one fraction, 5 plus 2 times x minus 3 over x minus 3. I get 5 plus 2x minus 6 over x minus 3, which simplifies down to 2x minus 1 over x minus 3. Now I want you to notice when I take a translated reciprocal function and write it as a rational function, translated reciprocal function, written as a rational function, gives me a ratio of 2 linear functions. In other words, 2x minus 1 is linear. Y equals 2x minus 1 would give you a straight line. X minus 3 is linear. Y equals x minus 3 would give you a straight line. We're going to think of those in terms of ax plus b over cx plus d, two linear equations. Now let's see what we would need to do to graph those. Here I have that function. Well, the book tells you that you can get a lot of information straight from this, and it is true. I can get my vertical asymptote is x is equal to what makes this fraction undefined, which would be 3. And I can get my vertical asymptote. We learned early in the year that that's simply the ratio of the lead coefficients, so 2 over 1 or 2. So I could get those. I could get my x and y intercepts pretty easy, but what I can't get is those translated points. I personally think that it's easiest to graph a rational function that is made up of 2 linear functions by turning it back into the reciprocal function. How do I do that? Well, I simply divide the x minus 3 into the 2x minus 1. X goes into 2x 2 times. Then I'm going to multiply the 2 times the x minus 3. That gives me 2x minus 6. I'm going to subtract negative 1 plus 6, because that was minus a negative 6, is 5. Since x won't go into 5, I have a remainder of 5 over x minus 3. So notice what I have. I've got the reciprocal function that is the translation. And so now I can work this the same way I did all the other ones. I take the f of x equal to 5 over x, and I translate it into f of x equal to 5 over x minus 3 plus 2. What did I do? I added 3 to the x and I added 2 to the y. So if I had 5, 1, that translates to 8, 3. If I had -5, -1, that translates to 3 to the right is -2, and 2 up is 1. If I had 1, 5, that translates to adding 3 gives me 4, and adding 2 gives me 5. No, adding 2 gives me 7. I was looking in the wrong place. And if I have -1, -5, adding 3 takes me to 2, and adding 2 takes me to -3. So let's look at what we have now. We said we have a vertical asymptote at x equals 3. That's right down through here. We have a horizontal asymptote at y equals 2. That's here. We have our points at 8, 3, and at 4, 7. So that gives me this half of the graph. We have other points at -2, 1, and at 2, -3. So this gives me this part of the graph. If I want, that doesn't go through 0, 0 though. If I want my accurate x and y intercepts, now I do agree it's probably easier to get those using this equation, although we do know how to find them using this one too. But using this equation, it's pretty easy. When I plug in zeros for x to get my y-intercept, I get 0 minus 1 over 0 minus 3, which is simply 1/3. So it goes through a y equal 1/3. To get my x-intercept, when y is 0, if I have a fraction and I want y to be 0, all I need to do is make the numerator equal to 0, and so I get x is 1/2. So I found out that it goes to x is 1/2. So I can get those too. Let's look at another example real quick. First thing I'm going to do is I'm going to change this. X plus 1 divided into -3x minus 1 goes -3 times. When I multiply around, I get -3x minus 3. So I subtract, which means add the opposite, so I get a 2. So I have 2 over x plus 1. So my function now becomes y equals 2 over x plus 1 minus 3. I see my horizontal asymptote is at y equal -3. I see my vertical asymptote is at x equals -1. I'm going to translate my points. My points for 2 over x would be 2, 1, 1, 2, -2, -1, and -1, -2. I remember what I'm doing is I'm going to say x minus 1, moving 1 to the left, and y minus 3. So let's see what we get. 2 minus 1 is 1. 1 minus 3 is -2. 1 minus 1 is 0. 2 minus 3 is -1. -2 minus 1 is -3. -1 minus 3 is -4. And -1 minus 1 is -2. And -2 minus 3 is -5. So let's plot those points. 1, -2, 0, -1. So that gives me the right side of this graph. -3, -4, and -2, -5 gives me the left side of this graph. Notice I already have my y-intercept. I may want to label this x-intercept, I can see it's going to be a negative fraction. How do we get that? Remember, when y is 0, that the numerator has to equal 0, so x comes out to be a 1 over negative 3, which is negative 1/3 right there. So I've got my graph. Pretty easy. This one is a little bit more complicated, but it's really not too bad if you'll stop and think about it. My 2x minus 1 divided into my 4x plus 3. 2x goes into 4x 2 times. 2 times 2x is 4x. 2 times negative 1 is negative 2. When I subtract, it ends up giving me 5. So I have 5 over 2x minus 1. So my f of x is going to be 5 over 2x minus 1 plus 2. Now this is translating those points. Remember, if this was just 5 over x, my points would be 5, 1, 1, 5, negative 5, negative 1, and negative 1, negative 5. Now, what is my translation going to do? Well, we know my y value is going to be plus 2. My x value is going to be moved to the right 1, so x plus 1. But I have a scale factor. If I multiply 2 times the x, that means that is a stretch, and it goes to a factor of 1/2, so I'm going to divide that by 2. So let's see what that gives us. 5 plus 1 is 6, divided by 2 is 3, and 1 plus 2 is 3. This one, 1 plus 1 is 2, divided by 2 is 1. 5 plus 2 is 7. Negative 5 plus 1 is negative 4, divided by 2 is negative 2, and negative 1 plus 2 is 1. Negative 1 plus 1 is 0, divided by 2 is 0. And then negative 5 plus 2 is negative 3. So now let's see where those are. First, let's get our horizontal and vertical asymptotes. Horizontal asymptote, y equals 2. Vertical asymptote, where this is 0, that would be at a positive 1/2. So now let's graph our points. 3, 3, 1, 2, 3, 1, 2, 3, and 1, 7 over 1 up 2, 3, 4, 5, 6, 7. And here we go. There's that half of it. Negative 2, 1, and 0, negative 3. 1, 2, 3. So here goes that half. Now notice this time we've already got the y-intercept, so we want the x-intercept. The x-intercept is when y is 0, so that is 0 is equal to 4x plus 3. So negative 3/4 is equal to x. So I should have drawn that on over this side just a little bit. Negative 3/4 is equal to x, and I have completed that one. The hardest thing about this one is remembering that when I multiply the 2 times the x, that gives me a scale factor of 1/2. So I'm going to add 1 and then divide by 2. We'll work on plenty of these in class tomorrow. I hope that this has worked for you.